Okay, so we knew, now we have talked about TCS, what is core Vita, the history of it, and what should be done, what are the basic things to be learned, and how should we get ready for it, what shouldn't be done, right? So now all of them have been talked about. Yeah, I'm the same guy who introduced TCS. A lot of difference talking about TCS and talking about coding. Coding, you'd find that Josh has to be there. You need that energy. Okay. And the first problem, what we have picked up is a basic, very simple, interesting problem. Prime Fibonacci. Did I hear somebody chuckling? Prime Fibonacci? TCS? Haha, exactly. We are always thinking that if I have to appear for TCS or any other MNC, they have to be asking about data structures and complicated algorithm and dynamic programming with three-dimensional data, and the time taken is going to be, come on, need not be. Let's not make such assumptions, right? Good. Yes, it is prime and Fibonacci. Let's have a look at the code, look at the program. Let's read this prime Fibonacci problem description. Given two numbers n1 and n2, find prime numbers between n1 and n2. I can hear you people, I know it. Exactly. So, whatever we have been doing in college, even the most smallest thing would be useful, ladies and gentlemen. Even the smallest, just writing a code to find out which is larger out of two numbers, if you think why, it is going to be useful. Everything is planned. Okay, so let's just come back here. Prime numbers between n1 and n2, I know how to do it. Okay, step 2, make all possible unique combinations of numbers from the prime number list you found in step 1. That's interesting. Normally, what do we do in the college? Given two numbers in between, you just print them and you're done. Here, they don't want that to be on the screen. They want that to be stored, to be reused. Got the point? So there is something little more important than what we have been doing. What is this combinations? Let's have a look at any examples. Yeah, they are here. Example 1, input 2 and 40, which means n1 is 2 and n2 is 40. And the prime number list is 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31 and 37. I know they are the prime numbers between 2 and 40. Cool. Combination 2, 3, 2, 5, 2, 7. Okay, getting a grip. 211 and then 213 and then 217 and then 219 and 223, 229, 31 and 37. And I don't have to combine with itself. Okay, got it. Next, 3235. I think, yeah, I think we are having a grip of it. Let's just go ahead. 37 starts over here. 37. So the first number is 2. So it is getting on the right end. So every other number is getting added on the right end. So 37 and then 2. 37 and the 3. 37 and a 5. 37 and a 7. 37, 11. Wow, wow, good. So now we have a solid grip of what is expected. Then what should we do? Okay, so this is a list to be generated. Interesting. And step 3, from this new list, okay, again find all prime numbers. Okay, so we need to have maybe we'll just think about, I think we need to write a function to find prime numbers, right? Yeah, even I feel so. So from this, if you have, so 193, 31, 37, okay, cool. So the third step is also can be done by us. I don't think no hassles. Step 4, Find the smallest and the largest from the second generated list. Also count of this. Fine. Okay. Also the count of this list. So in this you will find that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 34. Okay. And the smallest is 23. Let's check it out. Yeah, 23. And largest is 3719. Check it out. Yes. Anybody larger than that? No. So we found the smallest and largest. Then what do we do? Okay, their smallest is A and largest is B. Okay. Okay. I'm getting a hang of it. Therefore, the last number of the Fibonacci series is, which means I think right. Consider smallest and the largest number as the first and second number to generate Fibonacci series respectively till the count. Right. Good. And print the last number of Fibonacci series as an output. This means I need only one number that has to be on the screen. Excellent. Let's do a small summarization. Let's not underestimate TCS. Every problem they give you, even if it is going to be on a pre-qualifier round or on a qualifier round, you need to be a bit careful. Okay, let me bless you. Okay, can I bless you? Why not? But 54 years old man definitely can bless you, and 32 years of experience definitely can bless you, right? So let me bless you. Every listener of this particular program, may you cross the pre-qualifier round and go down to the next round. Okay. Every problem always has a small little hitch, a little twist in the code. Okay. Now let's find out where is that. Let's be a little cool. I don't think it's going to be too complicated, but anyway. Okay. Let's just put it into algorithm. Maybe we should be able to do it. Okay, algorithm. Okay, here it goes. Find the prime numbers in the range n1 and n2. Okay, determine the size of the array required. Why? Because we need to store all the prime numbers. What are the various factors that should be running onto the mind? The number of prime numbers in the range 2 and 100, because I still can remember. Look at it. Constraints. N1 is less than or equal to 2. N2 is less than or equal to 100. So keeping this in my mind, not more than 25 prime numbers. Not more than 25. Why? Between 2 and 100, you have 25 prime numbers. First 100 has got 25 prime numbers. First 1000 has got 168 prime numbers. 10,000 has got 1229. 1 lakh has got 9296 or 9298. So tentatively keeping this in mind, I can say, hey, I will have an array of 25. One option. Second option, why are you bothered about the entire range? Look at the range. What is the distance between N2 and N1? For example, in 2 and 70, it is 68, right? Or 70 or 2 and 40. 2 and 40, what did they give us? 2 and 40, 38. So of this 38, definitely you would find half of them would be even numbers. So I can just say here, okay, that is going to be 40 minus 2, right? So it's going to be 38. Out of 38, you divide it by 2, you get 19. So worst case, 19. Cool, perfectly got it. Right? So I think that this should be sufficient. You don't have to be accurate. You don't have to be same time. You don't have to be extravagant also. So 19 seems to be a better option. There isn't anything wrong. Okay, we can do it. Write a function to combine given two integers. How do we combine? That is a little tricky. Let's say we take a prime number 13 and another prime number, though it is not. Okay, let me just take 97. Is a prime number. Okay, so if I combine this, it should become 9 13,000, okay, 1397. So mathematically speaking, 1300, okay, I took a break, and 97. So that becomes 1397. So of the two numbers, who can become 1300? Obvious. 13 into 100 plus 97. Okay, that's pretty much easy. But how do you get this 100? Simple. If a two-digit number has to sit next to a number, he should give space for two digits. So how do you give space for two digits? You multiply by 100, you get two-digit space. If it's going to be a single digit, multiply by 10. It's going to be three-digit, multiply by 1000. Fine. So we need to combine, we understand. Write a function to check uniqueness. Not a function, okay, you need to have the code. I've just made write a function. I was looking forward much more, okay. That's also going to be easy. It is going to be unique, okay, that's fine. Min-max is going to be cool. We have been doing it n times n. Generate Fibonacci, yeah, that's also cool. I think we can now move down into code. But also let's just have a look at, it's always a good practice. Always a good practice. Okay, the input is N1 and N2, 30 and 70. Okay, see, you need to understand, when we are working with a laptop and when we have enough amount of time, we'll have time to generate all these things. But do you think you would be able to? You might not be able to, but you have to work with a smaller quantity. So what are the prime numbers in this range? These are the prime numbers: 31, 37, 41, 43, 47, 53, 59, 61 and 67. You may be wondering, come on, how can I manually do it? Okay, take a smaller wrist. Okay, make make N1 as 2 and make N2 as, say, 20. I think that is sensible. So you need to find all the prime numbers in that range. So what would be the prime numbers? 2 is a prime number, 3 is a prime number, 7 is a prime number. Let me make it a little bigger before you start screaming. Okay, cool. And then 8 is not, 9 is not, 10 is not, 11, 12 is not, 13, 14 is not, 15 is not, 16 is not, 17, 18 is not, 19, done. So we have this. Now you need to make a combination. If you find you don't want to go until, make it as 15. You will have 5 numbers. Fair. But you ought to see, let's make it very, very clear. That's why this is the first time you are watching us. But I'm just showing exactly what will help you solve problems. Dear ladies and gentlemen, I am really concerned. I don't want to just close. I can do the same code in 15 minutes and allow you to just have a look at the code. Why am I spending nearly an hour? Because I have a concern about you. I want you to understand how to do coding. Why? Because even in a pre-qualifier round, if you cross one problem or one and a half problems, there is a possibility you will get a letter, a call letter. And then after that, it is your smartness. Right? I can't do much of help there. But till that, I want to be really helpful. So at least, if not 20, okay, go on to 15. So you'll find that this would not be there. At least 5 numbers would be there. Work with that. Then combine them. So here I have taken time to combine. 31 combined with everything. 37 combined with 41 combined. 43 combined. 47 combined. 53 combined. 59 combined. 61 combined. 67 combined. Now these are the combinations. From this prime ones. The yellow ones are thrown away. They are not a prime number. Let me tell you, honestly speaking, how did I avoid few numbers? For example, I did this manually. I poured yellow onto this. 3147 cannot be a prime number. Simple. 3 plus 1 is 4. 4 plus 4 is 8. 8 plus 7 is 15. 15 is divisible by 3. No. It cannot be a prime number. Honestly speaking, 80% of them was manually done by me. 20% was helped by my team, Priya and Selva Kumar. They were sitting with me and they helped me. This particular number are the prime numbers. So the green one are the prime numbers. Cool. This is a very comfortable thing. Obviously, this is the smallest, right? And this is the largest. 3137 and the 6761. Cool. How many of them are there? We did not do. Let's count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12 and 14. So I need to find out the 14th Fibonacci number with smallest, that is 3137 as the first number, 6761 as the second number. Get it? Job done. Answer is 2027041. Let's verify with the problem statement. 20 to 7041. So which means my understanding with TCS goes good. Now I think it's time where we can start coding. Okay, fine. There is one area I would definitely like to discuss before I move forward. Okay, this second list, how are we going to store it? Because either we may have to store it or we need not store it. Okay, but I think every combination what we make can be checked whether it is a prime number. That shouldn't be an issue. But what if there is a duplicate? So we have to store that. Let's look at how many of this would come down. That is going to be cool, because if there are 12 numbers here, every number is going to be combined with 11 other number. So 12 numbers combined with 11 other numbers, 12 into 11. Right? That is going to be the maximum possibility if everybody becomes a prime number. It is not going to be, but we do not know how much. So jolly well be ready for the worst case. That is, how many of our prime numbers we have, that multiplied by that count minus 1, because 12 multiplied by 11, because every person, for example, you got in a game. Okay, let's say there's a party going on. Okay, there are 12 people. Everybody goes down and performs a handshake with everybody, comes back and sits down. There are 12 people. So how many? It's not how many handshakes. The total handshakes is going to be something like one person got up, he went around. Of course, obvious he won't shake. He won't handshake with himself. So 11, he sits down. Second person, another 11. How many of them? 12 people. So 12 into 11. Exactly the same thing. Cool. So I think we are ready for coding. Okay. And I think we have spoken enough. Maybe 20 minutes. 20 minutes. I think 20 minutes of thought process. That's the most. 20 minutes of thought process. I think we should go ahead and code. So my choice is going to be C for coding today. And 90% of the time I'm going to start with C. But we also have plans to show it multiple platforms. We will be able to help you with Python, as well as we're planning to help you with Java too. So hash include stdio.h, standard input output.h, and int main. We'll go slow, no mad rush. I keep saying this. Don't get tensed at all. Fine. If you remember when I was talking about TCS, I said the last point I would like to mention is keep your head on your shoulders. Because even if you pick up 2 problems from the 6th problem, and if you can crack it, great. So cool, that's the most important feature. Return 0. Okay, fine. So let's have 2 variables, n1 and n2, and n1 equal to 2 and n2 equal to 40. Every step I will make you people understand. So first we need to make all numbers from n1 to n2. So let's have another guy, another identifier num, and he would help us generate values from n1 to n2. Okay, so my code becomes for num equal to n1, num less than or equal to n2, num plus plus. Cool. So I am able to generate value from n1 to n2. Okay, now we need to check whether the number is a prime number. Look at it, down top approach. That is, if I start working, if is prime. Okay, I haven't written, I will write, I need to write. Okay, if I give the num to him, and if he tells me, yeah, that is a prime number, then I am interested in him. So let us get this particular line number 11 stable. Let's go write a function int is prime, and what is the parameter? Int. So this is the function signature, and he wants to, we have decided that he should give me prime. So what is this prime? Now this you would find that are some of the benefits of working with C. In fact, honestly speaking, when we launched this particular announcement of webinar, I wanted to shout clearly, this is going to be more of algorithm and C. I'm not going to choose. There are 8 languages what TCS allows me to choose, but I'm not going to take the liberty of choosing one of them. Why? Because highly problem specific. So I would rather choose one language that is going to be suitable for everybody. Maybe the number of lines might go a little high. That's fine for me. That's fine for me. I very well know this particular problem, I can solve that in Python short code. I'm not denying the fact. But when I do it in C, the person who looks at this code, I can showcase how good am I in my logic. When I do coding in Python, I always try to make all the features of Python possibly put into the code and write my code short, 10 line. But you would find that when anybody looks at the code, they won't understand head or tail or the stomach part of it. They would not be able to stomach any Python code. It takes time for them to understand. But when you write a good C code, that would be easy for anybody to understand. So that is the concept. So define prime. Why? Because I can use 1. But the problem is when somebody sees 1, they would see it as a number 1. That is all. What is 1? 1, 0, they don't understand. So now if I use the word prime, okay, that's much, it is intuitive. Is prime is a function and num is given as a parameter, and he shouts, hey, it's prime. That's much easier to understand. What in case if you want to shout not prime? Okay, let's define it. Define not prime. 0. Cool. Now let's write the is prime. Remember, absolutely no tension. That is the most important part of programming. Heart is the first one that has to get involved. Okay. So this is function definition. You're talking, elaborating it. Okay. I mean exactly what it is. So is prime is the name of the function, Okay, you would give me a number. Cool. Now let me find out what are the various conditions. What are the various conditions which I can be sure it is a prime number first. So if the given number is 2 or given number is 3 or given number is 5. Okay, these three are known prime numbers to me. I have a reason for doing this. I have a reason for doing this. Let's say, for example, I don't know, I'm talking to every one of you personally. Let's say there is a Praveen there who is sitting down and listening to me. Let's talk to the Praveen there. Okay, or Karthik, or Raji, or Shweta, or Sridhar. Somebody there. Now, what is this person doing? This person is planning for the interview, ladies and gentlemen. When this code has been written, I don't know how many of you have been reading about code Vita. Every person who have had the interview experience have said this. Hey guys, remember every problem, whatever you solved, jolly well remember the code what you had written because it's going to be checked. So, I am preparing for my interview. You don't think I'm coding. No. I am preparing to meet the interviewer of TCS. Let me brief you later, little back. Okay, return prime. Okay, now I'm going to choose some people who are not prime. If number is less than or equal to 1, you give me 1 or 0 or any negative number, come on, they are not prime numbers. Or num divided by 2 gives me 0 remainder, the even numbers. Return not prime. So these are some obvious cases. Otherwise, what would I do? I would start hunting for factors. Let me just call this as check factors. The name what you choose for a variable once again solves 20 to 30% of your problem. I could have chosen I, J, K. There are 26 letters. Have you seen anybody giving a function name IJK? Why don't you catch hold of the collar and say, why don't you give the function name also IJK? For a function name, they want to have something which is meaningful. But the moment you step inside for identifiers, awful. So dear students, dear listeners, never ever do that mistake. Good. Next, where is my hunting area? The factors are always available in the range of, for specifically prime numbers of our search, 3 to the square root. Okay, so I have to work until the square root. Look at my variable name, until. The check factor would be moving until a specific value. Okay, I understand. So what is the until? Until is equal to square root of the num what you have given me. The moment you use square root, go up and just include math.h. Hash include math.h. Because sometimes I have forgotten this and that has given me a lot of trouble. It would work, but it would not work the way I wanted him to, right? So I'm not going to make this mistake once again. For factor equal to 3, for check factor equal to 3. Why? Because everybody who is divisible by 2 have been already stopped by me. Starts from 3. How long will I go? Check factor has got to be less than or equal to until. Okay. What is my alteration? Alteration is check factor would get incremented by 2 every time. Why not 1? Because even numbers have been thrown away. So don't bother about them. Cool. Next. Find out the check factor, whether he is a factor. Okay, let's do it. If my num divided by, note down the way I am saying it. I'm not saying num modulo check factor. Num divided by check factor gives me a remainder, because if I would have said num slash num divided by check factor equal to the quotient. So when you say percentage, that gives you the remainder. If it is equal to 0, that is a factor. Then immediately get out and scream not prime. Now, if you happen to cross and come down to line number 28, it means you hunted and you never found a factor. If you don't find a factor, hey, that guy is a prime number. Cool. Return prime. So we are done. So now what do we do to this number? We need to store this guy inside an array of a specific size, and that is, focus please, and that is determined only during execution time. So remember this, either make it as 25, one option. I'm not saying no to it. I'm not saying if somebody says 25, I wouldn't say that you are making a mistake. I'm still going with you. But for a professional coding, a little more than what any Tom, Dick and Harry can do, I think calculating 19 would be more advisable. So let us just find out. Okay, maybe I'll just have a count. Okay, count for primes. Okay, count for, okay, I think count for primes. Okay, let's calculate this. Count for primes is equal to my n2, okay, minus n1 plus 1. Okay, no, okay, yeah, the whole thing can be done divided by 2. Why? Because definitely you would find that half of them would be going off in even numbers. Divided by 2. Or if you find, hey, this divided by 2 is finding little bit uncomfortable for me, don't even have it, just say n2 minus n1 plus 1. It's still going to be fine for us, perfectly all right. So now I know how many numbers can be prime numbers. So how do I store it? Now look at it. If I know how much arrays, when you do not know how much, okay, let me determine the name of the array. Primes ARR. Focus please. Primes ARR. If I know it, put it in square brackets, the size. When you don't know it, you say, okay, I do not know. So what do? Just say, I do not know, put a semicolon and just say, let me just have one person called primes ARR who will hold an array during the execution time. So when it is primes ARR, you are, for example, I'm just saying, if you say 25, you are clearly saying, hey, there is an array called primes ARR whose size is 25. Or I'm just saying, I don't know. So there is an identifier called primes AR. Note down my statement. There is an identifier primes ARR who at runtime will hold the address of the array. Okay, agreed. So what do you start with? Null. Why? Because this guy is a little dangerous. Imagine somebody has got a gun and he is just pointing it arbitrarily. Accidentally, if he shoots, they may be find a damage. That is why we tell him, buddy, you are having a gun, point it to the ground. Ground them. So that's why nullify it. Null. Okay, done. So now what do? Once I know the count for primes, I can start. First thing, remember, we need to get memory. That is the most important thing. I'm going to use this. Do not bother. I will support you. At the end of this video, I will support by giving a small piece of video that will explain little more in detail. And that video is going to be available in YouTube. You can watch them any number of times. Cool. So how do we do it? Primes ARR is going to be allocated space right now. Who will do? malloc would do. malloc would do. And this point is getting reiterated at least 3 times in the next 6 days. So even though if you don't get a firm grip, okay, relax, grip, we will make it firmer. Okay, so what does malloc want? malloc wants, tell me how much bytes do you want? Okay, size of, because I'm going to store integers inside, size of int multiplied by my count for primes. Good. And why have you left one parenthesis over here? Because malloc is going to tell me where is the allocation done, in which address is where you can use. Okay, so what? Why do you have a parenthesis? And that address, he does not know the type of that address. Okay, yeah, I understand that, because I am the one who is buying memory. I am the one who would know what is going to be stored there. Right. So what is primes ARR going to store? Integer. So make it as, okay, that is an int type address. That's cool. Good. Now we need to use this array. Look at it. Primes ARR IND. Look at the habit. The index that is going to be working along with that would be declared in the same line. Don't have one line extending to the nearby screen. Sometimes you would find that you go a couple of computers away also. Don't do that. Fold it. Make it readable. Okay, cool. And now, okay, done. So let us put this prime number, whatever we have found, into this array. Primes ARR is equal of primes ARR IND equal to my num. Cool. And what am I expecting? I am expecting the number which I have found as a prime number should be sitting in location 0. But I haven't mentioned it. Which means equal to 0. Okay. Copy this. I have a habit. I don't initialize them along with the declaration. I always do it away. Okay. Cool. Equal to 0. Okay. Fine. Maybe it just adds up one line on the source, but it has got a lot of facility. Okay, good. Then what should you do? I think after this, the next prime number should be made to sit in 1. So I have to add 1 to it. So I can just add one more line, just saying primes ARR IND plus plus. Now, hey guys, I know some of you guys who code, they say, hey, come on, Sridhar, why don't you put that in line number 19? Okay, thank you. I heard you. Keep it inside. It's perfectly all right. Okay, but you know what will happen to any of you people who feel that I am doing additional line? For a person who's not confident about, see, this would be confusing. That is why store it and then you can add it. By adding one additional line, nothing is going to happen. And you can solve this in the interview. If the interviewer is going to ask you, why did you do this? You can say, hey, I could have done it, but I just wanted to be very simple for everybody to understand. And you are showing interest for others to understand is a good quality of yours. Cool. So I think step 1 is over. Then what should you do? We have to make all the combinations. All the combinations. Here, I'm going to combine my tasks. Please stay tight. I'm going to combine them. So first of all, let me find out how many numbers of prime numbers can be happening. Remember, worst case. What is that? How many ever prime numbers we created, that multiplied by. For example, first time this was 0 and he became 1. He was 1, he became 2. So you can see here the primes A, R, I and D is also telling me how many prime numbers are there. Can we just check this out? Okay, printf and just say percentage %d. In fact, actually, you will find we can just have a agile methodology. Check whether all the numbers are available for I and D equal to 0, I and D less than, primes A, R, R, I and D plus plus, and print it. Okay, percentage %d, comma, yeah, primes ARR, primes ARR of primes AR IND. Cool, IND. Paka. Let's quickly run this. Now I'm going to slowly increase my pace little bit. Don't bother. Okay, fine. Cool. So IND is not declared obvious, then obvious. Okay, come on, IND. And run it 2 and 40. Output should be 2, 3, 5, 7. Oh my god. Okay, what is that which is getting in between? Have I made a mistake? This is 0, this becomes 1. And then it becomes 1, this becomes 2. Right? Okay, or shall we just make this plus plus and comment it and see if this guy is working? Let's check it out. That's where we made a mistake. So 2, 3, 5, 7, is it visible for you? Let me make it a little more comfortable for you. That's much better. 2, 3, 5, 7, 11, 13, 17, 19, 23, 20, 30. Exactly. So my first task is over. Now we have to combine them. Now we need to combine them. Okay. So for combining, I want a function who will do the combining. Okay. So look at it. This time I'm doing a top-down approach. That is, I'm going to write a function called combi. Int combine. Okay, make it combine. You give me 2 integers, I will give you combination and 1 integer. How would I do? Int combine. You would give me num1, you would give me num2. Okay, let me just think about it. Okay, you are giving me num1, for example, you are giving me 11 and you are giving me 197. So what should I do? I will walk on num2. Focus. I'll walk on num2 until he becomes nobody. What do you mean by that? If I divide 197 by 10, he becomes 19. Okay, he becomes 19. And if I further divide 19 by 10, he becomes 1. And if I further divide 1 by 10, he becomes 0. Cool. So 3 times I'll walk. Every time I walk, I would immediately carry a power 1, 10, 100, 1000 and so on. Right? So 3 times if I do, I have to multiply 3 times. 1 into 10, 10. 10 into 10, 100. 10 into 100 and 10, 1000. Okay, I'm getting it. I'm getting it. So I need to have 1 power start with 1. Okay, and I'm going to lose my num2, but I need the num2. Okay, I'll call this as let's have one called to process, so that I won't lose my focus, please. Good. I'm getting it. To process is equal to num2. Okay, let's process this to process. What would I do? I would say to process is equal to, okay, or slash equal to 10. Divide him by 10. Immediately say power star equal to 10. So he becomes 10. Now this goes on a loop. Okay, how long will he do? This will go on in a loop until the to process becomes 0. Okay, while to process not equal to 0. Okay, or better coding would be, you can also say while to process. I'm satisfying both people who understand while to process and while to process not equal to 0. Either one you can do. I think we have arrived at the final step. Once you know the power, all you have to do is just finally just say num1 return num1 multiplied by my power add num2. Cool. Combination is ready. Cool. Then let's go back and do this little task of making memory allocation and then over. Okay. So let's just have one more. This is primes ARR. I'm going to have one more called combi primes ARR. Okay, do you know the size? I'm sorry, I don't know. Okay, fine, start. Who's going to be in that? Integer, fine. And where do you start him? As usual, start him with null. Okay, who would be helping in working with him? Combi primes ARR IND. Where would he start? He would start with 0. So along with this, let's just get the first of all, get the memory done. Very, very important. Okay, let's have one more count. Count is equal to, what is that? How many ever prime numbers we have, which is got primes ARIND multiplied by primes ARIND minus 1. Okay, so now I know how many can be there in the combination. If you want, you can have one called combi count. Fine, no problems, perfectly alright. If you feel, hey Sridhar, we will use the count for that and for this, fine. Count for primes. So count for combi. Count for combi. So that it makes it look good. Okay, keep it, no issues. Count for combi. Cool. Now do the memory allocation. Count for, I'm sorry, it's going to be primes. Combi primes ARR is equal to, remember, typecasting, malloc size of int, size of int multiplied by how many? Count for combi. So Control C and Control V. Okay, cool. Remember, we need to combine that and put it into remember, typecasting. Cool. Now we have memory. Now before I put him inside, I need to check whether somebody is there with the same value. Remember that. And I have to check whether he is a prime. So, okay, you got it. I'm going to make and call combi val. What would he be? Stay tight. From the primes ARR, take the first element combined with everybody. Second element combined with everybody. Have we done this anywhere? Yes. It's going to be a for inside a for, a nested for. So for nested for, I have a way of doing it. For out IND equal to 0. Okay, standard method. Out IND less than how many? Who's the count? Primes ARIND has got the count. So primes ARIND and out IND plus. Same. You would find that lot of times we use same code. And inside that, one more stepping for in IND equal to 0. In IND less than my primes ARIND. I'm sorry. Primes ARIND in IND plus. Cool. Now this will take me for a perfect loop inside a loop. Inside that, first make a combi val. So what is combi val equal to? So combival is equal to I need to combine. Focus please. Combine two elements. Who are that? Primes ARR of out IND. I think we need to declare this quickly so that you will find that it helps us. I would love to do that. So let us have one out IND and one in IND and one combival. Okay, let's have one more line, nothing wrong. Int combival. Cool, perfect, good. So comma the first out IND. With all that, you will find that we do the in IND. So primes ARR of in IND. That's it. Now remember, I need to store this combival inside my combi primes ARR only if he is a prime. So first, if is prime of combival is equal to prime. First thing, is he a prime number? Check it out. If he is a prime number, there's one more thing. Remember, he has to be unique. What do you mean by that? In this array, he should not be existing. In this array, he should not be existing. So we need one more helper. Who? A guy, find hardly 4 lines, a guy who would find out whether the data is unique. Int is unique. So what would we give him? We would give him one array, we would give him one size, and we would give him one search val. He would say whether the search val is there. If it is there, not unique. Not there, unique. So let us have the same way of defining hash. Define unique 1. Hash define not unique 0. Cool. So let's just write the code. Let's just have this prototype copied so that we can go down and write the code. So write the code to check whether it is prime, whether it is unique or not. Okay, hardly 3 lines. Okay, so I have an IND. I will walk on ARR for IND equal to 0, IND less than size, IND plus plus. Okay, I'm walking. And if I meet the search val, okay, if ARR of IND is equal to search val, okay, what do you mean it is equal? It means that value is already there. Okay, then all you have to say is return not unique. Okay, if he crosses the entire array and if he comes out, then he is unique because he didn't find the value at all. Return unique. That's it. Over 5 lines. So, and okay, let's put it in second line so it'll be easier for us to understand. And is unique. Is unique. So who is the array here? Remember, combi primes ARR is the array. Who knows the size? Combi primes ARR IND knows the size. And what is the value to be searched? Combi val is the value to be searched. If it is equal to unique, then yes, I want him with me. Okay, now look at it. Along with this, let us also find out the smallest and the largest. Job over. So that you will find that we can quicken. We don't have to walk once again for the smallest and largest. Cool. So if my combi val, who is going to be stored inside the array, I check. You find out, are you smaller than smallest? Remember, they had said find the smallest and largest. Okay, smallest and the largest. So if it is smaller than the smallest, you are the one who is now smallest. Okay, sorry, smallest is equal to combi val. Next, on the other side, if the combi val is greater than the greatest, okay, we need to define that. Don't bother, we will define. Then greatest is equal to combi val. So in one cull, many mangas. So in one loop, many achievement equal to combi val. So let's go down and define the greatest K. Then what do? You need to store them. Okay, combi, same way how we did primes. Okay, combi primes ARR of IND plus plus equal to combi val. That's what I said. This area alone, multiple things done at the same time. That's all. Job done. Job done. Job done. Okay. Then, so we need to define these two variables, smallest and the largest. Be careful whenever you work with smallest and the largest or greatest. Okay, we have a common method of doing it. How? Ensure the greatest is smallest value. Okay, look at it. Smallest is equal to get the maximum possible value, which is int max. Int underscore max. And the greatest gets the smallest possible value, which is going to be int min. So where are these constants coming down from? They come down from limits.h. So hash include limits.h. As we are here, ladies and gentlemen, let's just also add hash include malloc.h or stdlib.h. If anybody tells you header file has got all the functions, punch them on the nose. Header files do not have any functions. They have only function signatures. Right? Good. So now I think it's done. So let's find out, print and see what is the smallest and the largest. Percentage D, what is the smallest and what is the largest. So next time, checking time for us, if all is well. Okay, greatest. Right, now let's run and see if all goes well. Okay, I know there's something wrong. Simple, most probably we would not have initialized some variables. I know specifically which variable I would not have done. Here goes. Who's the guy? The combi primes ARR IND should have started with 0. I know this I would have missed it. 23 and 379. Exactly. If I give 30 and 70. No, let us have a look at it. I am excited. 30 and 70. It should be 31376761. Wow. 30 and 70. Tongue. Exactly. Now all we need to do is get the Fibonacci number. Okay, let's just get it. But do remember here, care. Why? Because look at my data type. Why am I using long int? Remember, ladies and gentlemen, Fibonacci series is always a epic, classical example of arithmetic progression. Just like that, you would find that it can become a tsunami. So I don't want to make the mistake. Term 1, term 1, okay, sorry, term 1 and term 2 and term 3. Okay, and for counting this, I'm going to have one guy called Fibo counter. Okay, so I think a simple code would be sufficient. Let me comment this printf and just say, okay, term 1 is equal to the smallest, and term 2 is equal to the greatest, greatest. Okay, and the next term is term 3, that becomes my term 1 and plus my term 2. So how long should I be going on? I should be just going on. Okay, now we'll say for my Fibo counter starts with 3. Why? Because 3 numbers have been generated. My Fibo counter should be less than, focus please, primes, no, combi primes ARRIND. He is the one who has got total number of combinations, and Fibo CTR plus plus. Okay, cool. And inside that, you need to just shift the window. Term 1 gets term 2's value, and term 2 gets term 3's value, and there's going to be another term 3 calculated. So Control C and Control V. So when you come out, all we need to do is just say printf term 3. Printf term 3. I'm sorry, percentage LLD, and just say term 3. So for 30 and 70, what was the answer? Let's just try it out. Let's try it out. 2027041 exactly. Right? And I remember this number, but the other number, I'm sorry, I don't remember, honestly speaking. That was a huge number. Remember, I told you about more than the Indian population. 2 and 40. Okay. Let's run this and see what's happening. Wow. I'm sure it is right. I'm sure it is right. Look at it. Nailed it. 131-5800-6689. Nailed it. Cool. There's one thing very, very important. Whenever we have been buying memory, the last thing what you should do is set them free. Okay. Before we close down, just say here free. 2 guys. Who are the people? One guy is primes ARR. Second guy is free combi primes ARR. And all you need to do is, once that is done, submit your code. Ladies and gentlemen, TCS is waiting for calling for an interview. How long did we take? 1 hour, 3 minutes and 30 seconds. Did we rush? No. We were very slow. We talked enough about looking at the problem, looking at the algorithm, which means 40 minutes, 45 minutes, 50 minutes, cool. Perfectly all right. I think it's time for winding up now for us. So we completed prime Fibonacci. And then I think we are done. And what I'm going to do is, I'll help you people go through whatever has been done, which was like specifically dynamic memory allocation, by looking at a short video now. Okay, so I'll see you tomorrow with a fresh problem statement. For tomorrow also, you would find that once again I have picked up one problem statement with dynamic memory allocation, and one problem, very, very simple problem. Trust me, very simple problem. Would anybody believe that tomorrow we are going to do a code on pattern? Haha. Exactly, ladies and gentlemen. So tomorrow, you may be wondering, TCS pattern printing? Yeah, exactly. Good. So I'll see you again tomorrow. Till then, bye bye. Take care. Thank you for watching this video and keep visiting and keep staying with us again and again. And stay safe, stay at home. Thank you.